Welcome again. We are today going to be analyzing more of how we look at our numbers in chemistry. Try to relate this to math that you should recognize from middle school. But we will move on to what we call dimensional analysis, which is the way we will convert simple ratios into a series of number conversions. We'll go ahead and get started. So dimensional analysis is how we will transform one unit into another. It is the way we're going to set up a series of conversion factors so that we can convert one unit to another, or by either multiplying the units together or dividing the units and canceling them along the way. If you are good at dimensional analysis, if we develop some degree of skill of dimensional analysis, we do not need to memorize formulas. Just looking at units of our answer and the units we are given, we can essentially determine all we need to know. So if I calculate the area of a room, area is length times width. However, if I'm given the dimensions of the room, 10 by 20, and I'm told the area is meters squared, I know 10 meters times 20 meters is going to be 200 meters squared. And that's because, here, I'm going to pull up this. Give me a second. So, real quick, a reminder, if I'm doing numbers, I can do simple math. 2m times 3m. Remember, we can split this up into 2 times 3 and m times m. You can split that up into those two different aspects. Okay. Well, 2 times 3 is 6. Well, m is assumed to be m to the first and m to the first. We just said if they are the same, we can treat that as m1 plus 1. That becomes m squared. Also, when we divide, let's see, 8 grams divided by 4 grams per milliliter, we can make our things easier. Writing that, you can write that as 8 grams over 1 times 4 grams over 4 grams per milliliter, which can be rewritten again as 8 grams over 1 times 1 milliliter over 4 grams. Well, we can simplify this. Number. 8 has common factors of 2 and 2 and 2. 4 has a common factor of 2 and 2. So writing that out, we have 2 times 2 times 2 times grams. And we're multiplying this by 1 milliliter. We have 2 by 2 by grams. Everything that is identical can be simplified out. One factor of 2 can be removed. a second factor of 2 can be removed. The third factor 2 cannot. So we're left with 2 times 1. And we also left with grams times milliliter, but we'll also have another unit of grams. Because these are 2 of the same factors, they will cancel out. And my answer just becomes 2 milliliters. That by carefully showing my units, I will cancel guys out. Now, in middle school, you might have been able to do something like this. You'd say, like, well, the density is 1.9 grams per milliliter. And I have a grams per 1 milliliter. And I have 10 grams. What is my volume? And you would set up a ratio like this. 10 grams over X milliliters equals 1.9 grams over 1 milliliter. And we would solve for this unknown ratio. And how we would do that is cross multiplying. And so you would get 10 grams times 1 milliliter, 1.9 grams times X milliliters. And then we would divide both sides by 1.9 grams. And so you'd have 10 divided by 1.9 milliliters is equal to my answer. Now, you can do this for some of these problems. However, some of these problems will also have multiple steps. And if we're going about trying to solve these multiple steps, setting up half a dozen ratios each problem can become tedious. So the dimensional analysis I'm going to attempt to teach you is a shortcut that will, because we're always doing the same thing, because what did we do to get this? What did we do to get this? We took my 10 grams and we divided by 1.9 grams per milliliter. We did this, and that is 10 grams times 1 milliliter. We flip this over. We flip the ratio over to get the ideal. We flip the ratio over to get the ideal. So what if it, instead of 1.9 per 1, it was 1.9 over 5? Well, then we would have had 10 grams times 5 milliliters over 1.9 grams. We would have just flipping the ratio, and we're multiplying, as we'll see coming up. So calculate density. 5 grams of solid, a volume of 1.85 milliliters. You can see here, if I know the density is a gram per milliliter, I know I need grams unit on top. I need 1.85 on bottom, because the milliliters are on bottom. And if they're not the same units, they do not cancel out. So when 2 units are the same type on opposite sides, they cancel. When 2 units are on the same side, they will combine. That's how velocity divided by time gives you meters per second squared, because you have seconds times seconds. And any units that do not cancel must be part of your final answer. So if we're very careful with watching our units, everything should make sense in the end. So the way I do it mathematically, I start by writing down a given value with units over 1. That makes sure that this turns an integer into a rational number, which is a number that says a ratio, and it makes sure we know what's on the numerator and what's on the denominator, because we're multiplying all the numerators together, we're multiplying all the denominators together. We need to figure out our conversion factor, and we're going to multiply that conversion factor so that the units that need to be canceled out are opposed on the opposite numerator or denominator with the ones we're given. So it should always cancel out one of my given units and ideally get us closer to one of my desired units. So for example, if I'm starting with centimeters and I want to go to meters, I don't want the conversion to millimeters. That is taking me further away. I would want the conversion from centimeters to meters. If I have feet and I want to go to miles, I don't want to convert to inches. I want to convert straight to miles. I want to figure out what conversion would get me closer. If you need to do multiple conversion factors, try to plan out your steps so that each guy gets you closer to where you need to be. You are trying to plan out your trip. If you're flying to Florida, you need to go, well, you plan out, okay, what flights will get us to the correct city? Where are those flights? What path do I need to drive to get to where the airport is? So if I drive into Memphis, so how do I get to Memphis? How do I get to the airport? Where's the flight? Is it going to the correct city? Do I need to drive to the correct city from there? You're planning it out, knowing where you need to end up and where you're starting from. You can work it out. Please note, if your starting factor is already a ratio, you may need to convert both the numerator unit and the denominator unit. So if I'm converting miles per hour to meters per second, I need to convert miles to meters, and I need to convert hours to seconds. So we have to do multiple conversions. However, just take each unit one at a time. Also, if there's an exponential unit like feet squared, you may have to convert multiple times. But so, simple conversions. So 250 meters to kilometers, 13 yards to inches, 35 millimeters of mercury to torr, and 5 centimeters squared to inches squared. Okay, with that in mind, let's look at these. Take them one at a time. Some of these are easy. I don't need to write down the conversions because I know them. Okay, 250, so let's start 250 meters over 1. Gonna multiply by what factor? Meters got to be on bottom, so kilometers should be on top. Kilometers are a big number, so there's a lot of meters in a kilometer. So we can write 1,000 meters in 1 kilometer. Now, meter, they cancel out. 250 by 1,000 should be 0.25 kilometers. I don't need to do the complex math to get that. Now, 13 yards. 13 yards to inches. Well, I don't know inches, yards in an inch, but I do know yards in a foot. So yard, foot, there is, in 1 yard, there is 3 feet. Now this is an exact number. So 13 is going to be the significant digits I'm going to work with. So yard, yard. Cancels our feet. We're going to do another one. Feet to inches. Once again, I know this one. 1 foot is 12 inches. Feet, feet. So in this case, it's just 13 times 3 times 12. Even though your answer gets 468 inches, we can only know these first 2 digits. So it becomes 470 inches because we don't know this any more accurately. We don't know, is it exactly 13 yards or is it about 13 yards? Now this one's just a little silly one, 35 millimeters of mercury. Well, we haven't seen this unit yet. That's not till much later. But there is 760 millimeters of mercury in 1 ATM. It's often good to take this all at once rather than to break it down individually. And you'll see why in this case. Oftentimes we can simplify things to make our life easier rather than doing multiple calculations. 1 millimeter mercury cancels out. Atmospheric cancels out. Well, what do you know? 760 is evenly divisible by 760. And so we have, that is just equal to 35 torr. We didn't have to do any work there. Then finally, 5.0 centimeters squared into inches squared. Well, we have to do this twice. There is 2.54 centimeters exactly in 1 inch. We're going to do that twice. Squared. So centimeters squared. We'll cancel centimeters squared. So we have 5 divided by 2.54 squared. And we get a big number, but we must round this to 2 significant digits. So we will round it to this place because we have 50. So it goes 0.78 inches squared. Only because we do not know this number any more accurately. So that is where we have to round it. It may not be where we want to round it, but that has to be where we round it. Now, last 2 slides. Density and temperature are two of the more complex equations we're going to be using this chapter. Not too much, not too bad, but we will use density and temperature. Density is simply the ratio of mass over volume. As I said, this is an intrinsic property. It doesn't depend on the amount of a matter. But one reason we would need density is because it can determine the chemical identity of a substance. We look at the density of fool's gold pyrite versus real gold. We can absolutely know which is which, as well as the melting point and other properties. If you compare various metals, we know aluminum is light, lead is heavy, and metals are variously dense in between. And by using those densities, we can figure out what this unknown silver metal is. But we can use this by using dimensional analysis or essentially one equation, we can calculate and derive all the other equations. That density is equal to mass over volume. That's the main equation I'll give you. But rearranging that, you can say density times volume is equal to the mass. Or volume is equal to the mass divided by the density. That if you're watching your units, you can interconvert. Now, temperature is the other interesting equation we'll look at. Temperature is literally the measurement of heat flow to and from an object. That we're measuring the temperature as it flows into a thermometer. We're comparing the relative temperature of a room to the temperature to the expansion of a liquid within a thermometer. The SI unit is Kelvin. However, we will often give numbers in Celsius. To convert between the two, Celsius we would add 273.15, usually 273, onto the Celsius value to convert it to Kelvin. So 0 degrees Celsius is 273.15. Now, why Kelvin? Well, Kelvin is a temperature scale that has a 0 point where we cannot go lower. The absolute 0 Kelvin is where all motion stops in the universe. So, on the atomic scale, atoms, even really cold atoms, are vibrating. If we chill an atom down to 0 degrees Kelvin, it stops vibrating. The electron stops spinning. A whole bunch of weird stuff happens if we get to 0 degrees Kelvin. It's still a linear scale, just like Celsius. It's just it has no zeros and no negatives. So 0 degree Kelvin is negative 273.15 Celsius. Now, we have a convenient formula to convert Celsius to Fahrenheit, but not so much one for Kelvin. But the formula, which if you need it, will usually be given, but it's 5 over 9 times the Fahrenheit minus 32. Or 9/5 Celsius plus 32 will give you Fahrenheit. Now, the reason why they're completely different scales has to do where they're calibrated off of. Celsius was calibrated off pure water. That the freezing point of pure water is 0 degrees Celsius, and the freezing point and the boiling point of pure water is 100 degrees Celsius. Now, that worked pretty well. Fahrenheit was calibrated off something different. It was calibrated on the freezing point of a brine solution. As you'll learn later, that salt water freezes at a lower temperature than pure water. So at this certain brine solution freezes at 0, which is why the freezing point of water is at 32 Fahrenheit instead. And the 100 scale was set at about where 96 Fahrenheit was believed to be the body temperature, which was inaccurate at the time, but still, I don't know why you wouldn't set that as 100, but it is what it is. But so that we all know that the body temperature is about 98 degrees. So either way, it was scaled in that way. But this was the earliest scale still in use. Now, I'm sure there's other ones before that, but they're no longer being used worldwide. But okay, we'll end this chapter with a few more math problems that we need to do. So we want to turn 13 grams with a density, so mass of 13 grams, a density of 2.7 grams per milliliter. And we want to know the volume. Problem 2. We have a volume of 32 milliliters and a density of 0.93 grams per milliliter. And we want to know the mass. And problem 3. is at what temperature Fahrenheit. So we want to convert 150 Kelvin to Fahrenheit. Okay. We'll go back to our document camera. I don't need much room for this, but our goal here is always first define what we know. We know 13 grams is the mass. We know the density. We know volume. Figure out, if we don't already know, the units of our volume and maybe what formula we'll need. I will not use formulas because I got dimensional analysis, but mass divided by density will give us volume. But once again, if I just start with my 13 grams over 1, and I multiply by the factor, so because that's grams on top, I need the 2.7 grams on bottom. Because this is just per milliliter, it's understood this to be 1 milliliter. So with that in mind, 13 divided by 2.7, units cancel, we get 4.8, yada, yada, yada. We round to 2 sig figs, 4.8 milliliters. We've defined for the second problem the volume, the density. We want to know the mass. Well, the equation is volume times density equals mass. However, just watching our units, all we need to do, 32 milliliters times 0.93 grams over 1 milliliter, units of grams. Milliliters and milliliters cancel, so we have 32 times 0.93. You get 29.76, which has to round to 30 grams. We don't want to report it as just 3. I know these 2 places. I do not know the tenths place, but I do know the ones place. So I had put a period there. And 150 Kelvin to Fahrenheit. Well, I know this is stupid, but we'll do this. 150 Kelvin to Fahrenheit. So the first thing is Celsius plus 273.15 is Kelvin. So that means Kelvin minus 273.15 is Celsius. So I have to get me closer, because I can convert Celsius to Fahrenheit. I cannot convert Kelvin. So 150 Kelvin minus 273.15. 50 minus 273. Now, we get, the answer is negative 123.15, which I think needs to at least round to negative 123. Maybe even 120. I have to look and see whether I included a decimal or not. The next equation is Celsius equals 5/9, and in parentheses Fahrenheit minus 32. So, rearranging that, 9/5 Celsius plus 32 is equal to Fahrenheit. Note that the plus there. So we'll take the negative 123 times 9 divided by 5, and then we're going to add 32 onto that. So negative 123 times 9/5 gets us negative 221.4. Then we add 32 onto that. We add 32 onto that, and we get negative 189.4, which rounds to negative 189 degrees Fahrenheit. 189 degrees Fahrenheit. Which we have to round to 190 because we only technically have 2 sig figs. Now, so please note, you will be given equations more times than not. However, if you are careful and methodical about showing your work, you're careful and methodical about canceling the units should always guide you towards the next answer, towards the next step. So please take your time, show your work. This is how we will get through this in one piece. Try to skip steps, we're going to have a hard time of it. With that in mind, that's as far as Chapter 1 progresses. Chapter 1 is a short chapter.